that involve inverse trig functions composed with other functions. Now, this technique needs to be recognized in the absence of being told when to apply it, and therefore we're going to present three problems here, one of which requires this new technique. Others require techniques we have seen before. This first one, for example, is something we have seen before, and it goes as follows. The integrand is simply the derivative of the arcsine function, and since the integral of the derivative is the function itself, so well, this is just the arcsine of x. So the arcsine of x plus c is what this integral evaluates to. If we take the derivative of the right-hand side, we get the integrand, and that's what it means to be an integral, or an antiderivative. The next function has a clear derivative relationship. Notice that the radicand of the denominator, 1 minus x to the fourth, well, it's a degree 4 term, while the numerator is degree 3 term. That degree 1 difference is a good indication that a u substitution is going to help. Take the derivative of my u and we get negative 4x cubed, multiply by dx, and then isolate dx. We see that dx is actually the same thing as du over negative 4x cubed. Now we substitute in this dx, and so our 8x cubed remains, square root u remains, multiplied by dx, which is now du over negative 4x cubed. And so the negative 4 goes into the 8 a negative 2 times. The negative 2 passes across the integration sign, and the x cubes cancel. So we're left with, on the inside, our du over radical u, and this just integrates to negative 2 u to the 1/2 over that 1/2. So we plus c. Now we multiply by 2 over 1 both sides of the numerator and the denominator, and that leaves us with negative 4 u to the 1/2, which is the same thing as negative 4 on the square root of 1 minus x to the fourth plus c. Now, this did not involve an inverse trig function, and that's what leads us to this last problem. In this last problem, notice this whole frame of work here does not apply. Why? Because on the first problem, my u is a degree 4 term, my du is a degree 3. So I see this du relationship. Here we don't have that. Here, my u, if you were to try a u substitution, you would say, u should be 1 minus x to the fourth. That is a degree 4 term. Its derivative is not present here, and we can't simply multiply by an x, say, squared to get it there with and canceling, because multiplying x's across the integration sign is something that doesn't make any sense. What does make sense is for us to realize that this kind of term relates to an inverse trig function in the following way. So let's go over here to the side and let me remind you of something. What is the derivative with respect to x of something like arc sine of, say, x squared? Well, that's the same thing if we set that x squared to be equal to u. This is the same thing by the chain rule. Is the derivative, first we'd have to take the derivative of with respect to u of arc sine u, and then we have to multiply by du dx. This is literally the chain rule. So the du of arc sine u is, of course, 1 over square root 1 minus u squared. And now we have to multiply by the derivative of u with respect to x, and that's just our 2x. So now we substitute this x squared back in, and so we see that you have a 2x on top over square root of 1 minus 2x squared. No, not 2x squared. X squared all squared, right? Because this x squared is equal to u, which is getting squared here. And so in the end, right, this simply is 2x over square root 1 minus x to the fourth. And this is very, very close. It's simply a constant multiple of what we have here. And so that constant multiple is something that can be taken care of with the integration. And it's going to go like this. So let's work here. So how are you going to solve this problem is as follows. First, you're going to think, I think this is a derivative of an arc sine u problem. And because that derivative is 1 over the square root of 1 minus u squared, I'm going to take the square root of this. So see how this is a u squared and this is an x to the fourth? So what that means is I should let my u, so we're going to set my u be x squared. So that means when I square it, it'll be x to the fourth, and it'll match what this given problem is. So then my du then is 2x dx, and I see that that's going to substitute in there nicely. So here we go. Now, if I simply divide by 2, now I can substitute in my x dx gets replaced by du over 2. So I have my integration, my 1 over square root 1 minus, instead of writing x to the fourth, well, I just square both sides, and I have u squared. So this is a u squared, and I'm multiplying by this du over 2, and let's just come down here and finish this. So the 1/2, this 2, comes all the way out in front, and I integrate 1 over square root 1 minus u squared du, and finally 1/2, this is exactly the antiderivative of arc, or this derivative of arc sine. So this is 1/2 arc sine of u plus c, which cleans up to 1/2 arc sine of, what was my u? Trace that up, x squared plus c. There you go. So this is very, very simply related to an arc sine problem. It's just on the inside, it's just an x squared, and we have this little constant out in front to account for that constant multiple. Okay, that's enough for right now.